Thank goodness we found you. We're from a group of survivors.
We have built a defensible sanctuary with weapons and food. We have a deep well supplied by an aquifer which has not been contaminated by the contagion. There's just one problem. Without power, we cannot run the pumps. We cannot get the water.
They said that you were an electrician. Before the world fell apart.
Will you help us? Teach us what electricity is.
Show us how to make a battery to start the pumps. Explain what an electric circuit is and how they work.
Come with us, journeyman. We need your skills for our group to survive.
Okay, I'll help you, but we can't stay here long. It's just not safe. Do you remember that all matter is made up of tiny particles called atoms? Each type of atom, oxygen, gold, copper, or even strontium-90, which cause this mess, well, they're all made from 3 basic building blocks. We've got protons, neutrons, and electrons. Protons and neutrons weigh about the same as each other. They're glued together in the center of the atom, in the nucleus. Floating around this nucleus are the electrons, which are absolutely minuscule in comparison. But even though they are tiny, electrons are very important, because they are not locked into the atom like the other particles are. Chemical reactions happen when atoms share, donate, or receive electrons to form molecules or charged ions. And if we've got a stream of energized electrons, and we push it from atom to atom along, say, a wire, we have electric current. But how can you possibly push something so tiny? That comes down to the charges associated with each particle. Neutrons don't have a charge, so we don't need to worry about them, but protons are positively charged, and electrons have an equal and opposite negative charge. Like charges repel each other, and opposite charges are attracted to one another. So if we manage to build up an excess of electrons somewhere that aren't balanced out by protons, the electrons will push each other outward, which could be down a wire to a load we want to power up. There are different ways that you can get this electric current, this electron flow, to happen. For a battery, we have at least 3 different parts to make 2 different chemical reactions happen. We make electrodes from 2 different metals. Depending on which metals we select, we can make a stronger or a weaker battery. These electrodes are in contact with the electrolyte, which can be a liquid or a moist paste. At one electrode, the metal reacts with the electrolyte in an oxidation reaction. In this type of chemical reaction, some electrons are shed from the atoms as ions are made. At the other electrode, a reduction reaction occurs. This type of chemical reaction requires extra electrons to make it work. We can move the excess electrons from one electrode, where they're being pushed away from one another, to the other side where they're needed by using an external wire to create an electric circuit. So an electric circuit is basically a continuous loop for electrons to flow around. We can start with conductors like copper wire. If we join the 2 ends to make a loop, we wouldn't have an electric circuit yet, though. The electrons have nothing pushing them around the loop. We could add a battery to the loop, and this would push the electrons around, but without a load to use the electric energy, the wires and the battery would get very hot, and they could burn. So we need a load to convert the electrical energy from these electrons to something useful like, say, light from a light bulb. We need these 3 different components to make an electric circuit work. Again, there's a source, such as a battery, to provide the electrical energy, that flow of electrons. Then we've got a load to use the electrical energy from these flowing electrons. And finally, there's the conductors to connect the load and the source together in a continuous loop. If we want to be able to control the circuit, maybe to turn it on and turn it off, we can add a control device, such as a switch. Now that's a quick explanation, and I can explain more later. I will help you make the electricity that you need to get your water. But right now, we have to get to safety. It's getting dark, and the infected, they'll be coming.